This is still a section 3-2 representing functions on page 150. Looking at example 2, equations as functions. So if you see an equation and you need to determine if it's a function, the first thing we look at is the form that the equation is in. So if you see an equation such as 2x minus y equals 6, how do we know if that's a function or not? Well, the first thing we look at is if it's in a specific form. If we see a form that's ax plus by equals c, we automatically know that that's a function. What does ax plus by equals c actually mean? So a would be our number between 1 and whatever, plus by, where b is a number and y is just hanging out there as y, equals c, and c is a number. So we're looking at this equation 2x minus y equals c. Now does it satisfy this ax plus by equals c? It actually does, because the ax in this equation is our 2x. We have a coefficient in front of our x, minus y, and in the original ax plus by equals c, that's the by part, where the b is a negative 1 times our y equals 6, and c is always a constant, and in this case we have just the number 6. So without even plotting it, we can say that this is a function because it's in that form ax plus by equals c. Now let's see, how do we double check that? Well, let's plot this on the graph. And how do we plot this on a graph? Well, we make a table. Let's start with a table. So if our table, we have x and y values, x and y, and we have this equation 2x minus y equals 6. If we plunk in a number for x, when we solve, we'll get the answer for y. So let's pick 3 values for x. Let's say we're going to put 1 in for x, 2 in for x, and 3. So now I have a table where the left column is our x, and underneath that I have a 1, I have a 2, and I have a 3 vertically underneath our x. So starting with our equation, let's put in the 1 for our x. So if we originally have 2x minus y equals 6, when we put our 1 in, we get 2, open parentheses, 1, close parentheses, minus y equals 6. Okay, now we only have one variable, and let's solve for that y. So 2, open parentheses, 1, close, is 2 times 1, or 2. So now we have 2 minus y equals 6. So we want to get this y by itself. We're solving for the y. So we have 2 minus y. So let's move this 2 over to the right. And since it's a plus 2, we subtract it. So we get minus y equals 6 minus 2. So y minus y, or negative y, equals 4. 6 minus 2. But now we have a negative y. So we need to divide or multiply each side by negative 1. So we multiply the left side by negative 1 and the right side by negative 1 to get that y to a positive. So then we'll end up with y equals negative 4. So y equals negative 4. What do we do with that? So in our table, the first number under our x value is 1. So right across under y, we put negative 4 as our y value. So in terms of an ordered pair, that would be open 1 comma negative 4 close parentheses. So now we have an ordered pair that we can plot on a graph. So then we take our next number that we're putting in for x, which we said was 2. So then we have 2 open parentheses 2 close minus y equals 6. And again, solving for that y. So 2 times 2 is 4, minus y equals 6. Move the 4 to the other side. So we have negative y equals 6 minus 4, which is negative y equals 2. Multiply each side by negative 1 again, so we can have a positive y. And we end up with y equals negative 2. So back at our table, we have the value of x of 2 underneath the 1. So under the y column, underneath the negative 4, we put negative 2. So now we have 2 comma negative 2 as our second ordered pair that we will then plot. So let's put our last number in. Our last x value we chose was a 3. So we then plunk it in for our x. So now we have 2 open, 3 close, minus y equals 6. Do the multiplication. 2 times 3, which is 6, minus y equals 6. Again, getting y by itself. Move the 6 to the other side. Negative y equals 6 minus 6. So negative y equals 0. And since it's equal to 0, we multiply each side by negative 1, and y equals 0. So again, we go back and put that in our table next to the 3 value under our x column. In our y column, we put a 0. So then that ordered pair is 3, 0. And we have all 3 of our ordered pairs. So let's now plot these ordered pairs that we created on a graph. How do we do that? Okay, so on the graph, starting at the origin, let's plot our first point, 1, negative 4. So that says from the origin, go 1 right, because that's our x value. So 1 right on the x-axis, and down 4, because it's a negative 4. So at 1, negative 4, plot a point. Our second value is at 2, negative 2. So we go over to the right 2 because it's positive, down 2 because it's negative. So we end up with a point at 2, negative 2. And lastly, we have our last point at 3, 0. So we move from the origin 3 units to the right and up 0. So this one's on the x-axis. Okay, so you can draw a line through these points, or throw on a wiki stick, or stick a pins in and put a rubber band around it. And now let's determine using the vertical line test if this is a function or not. So using your hand or a pencil or something, move a line across your graph and see how many times your line, vertical line, hits this graph. And if you notice, it only hits one point at a time when you're moving from left to right across your graph. So yes, this is a function. It is a function because we don't overlap. We are x values 1, 2, and 3. We have no repeat.